Hi guys, thanks for joining me. Today we're going to do 7.4. This is Trig Substitution. Alright. Again, it's just another method of integrating. That will allow us to integrate integrals that we've been unable to do prior. So there's a couple of giveaways to these types of problems because these problems are going to be mixed in with all the other problems from Chapter 7 and the integrals from Chapter 5. And that is the existence of a radical expression. So if I rewrite the original as x squared plus 1 rooted and then cubed, the fact that I have this radical expression in here, in combination with the fact that I cannot use U substitution, is a clue that trig substitution is probably going to be a method that's going to get this to work. All right, now I have a couple of rules in 7.4 that I've come up with on my own. They are not in the book. They work every time. They will never let you down. Just always follow them. All right, so let's clean this up here a little bit and make some room here. Now the way this is going to work is, in fact, let me just rewrite the original here. I think it'll be a little easier to see. This is 1 over the square root of x squared plus 1, the quantity cubed. All right. What we're going to do is, since I've got a radical expression with a sum underneath, I'm going to construct a right triangle. As the name implies, we're going to be using some right triangle trig. Now, according to the Pythagorean theorem, if I look just at the radical expression, just that part right in there, and think about how a triangle might be constructed using that expression, I'm going to get sides of x, 1, and the square root of x squared plus 1, if you think about how the Pythagorean theorem shakes out. The question is, where do I label them? Well, I think it might be obvious, I hope that it's obvious, that the hypotenuse is the square root of x squared plus 1. Let's get rid of this. The question then becomes, where do I put x and where do I put 1? Well, that brings me to the first tip that I've come up with. You want no cofunctions on the original substitution. Now I should mention this, trig substitution, like the name implies, what we're going to do is we're going to be taking out x's and we're going to be replacing them with equivalent statements in terms of theta. Much like we did with U substitution. If you recall, all the x's came out and we got a more simple integral in terms of U. Now, I should clarify that the original substitution is the trig function of theta and the ratio between, in this case, the variable side and the constant side. I'm not going to include the radical expression, so I want no cofunctions. So, for instance, if I put x here and I put 1 here, that's adjacent over opposite. That is the cotangent, but that is bad. That is a cofunction, and when I say cofunction, I literally mean trig functions with CO at the beginning. So I'm going to get rid of this. I'm going to switch out the x and the 1. And now, instead of the cotangent of theta, I'm going to have the tangent of theta. And that's good because it's not a cofunction. So let's get rid of this. Make some room here. Rewrite this. The tangent of theta is equal to x over 1. Now again, since I'm substituting theta in for x, I also need a statement as to what dx is. And I get that by deriving my original substitution. So if I derive that, I get dx on the right-hand side, and I get secant squared of theta d theta on the left-hand side. Now, I've almost got enough to substitute everything in the original problem. However, I still have this expression in the bottom. So what I want to do is set up another equation relating the radical to the constant side. I don't want to incorporate another x. I want to just have a constant, which again are easy to deal with. in integration. So I've got the hypotenuse over the adjacent. That is the secant of theta. I should mention this as well. Cofunctions are allowable for the derivative because you have no choice but to derive the original substitution. So don't sweat that. It's just this right here that cannot have a cofunction. If I take those three equations and I substitute it into the beginning, that's going to leave me 1 over the square root of x squared plus 1, which we already know is the secant of theta. That now is going to be cubed. Now you need to be careful here. The dx comes out, and I put in what it's equal to. That's the secant squared of theta d theta. These cancel. I bring the secant up to the top. That gives me the cosine of theta d theta, which is the sine of theta plus c. Now I don't want the sine of theta plus c. I want all my answers to be in terms of x. So let's get rid of this. And I'm going to show you what to do with it. I take the sine of theta plus c, and I come up with an equivalent statement in terms of x based upon my triangle. Well, the sine of that is the opposite over the hypotenuse. So I get x over the square root of x squared plus 1 plus c. And that, my friends, is the answer. All right, let's see here. Let me show you another one. Let's do this one. Integral of x over 1 minus x squared. This is also to the 3 halves dx. Terrible example because I can use U substitution. And by the way, U substitution problems will be included in the book, but since we're studying trig substitution, let's use it here. Right triangle, right angle, my theta. I think it's obvious that the hypotenuse needs to be 1 based upon the Pythagorean theorem. The question is, where do I put the x? Well, I can put it here, so x over 1, if I put it there, will give me opposite over hypotenuse. That's the sine of theta. That is not a cofunction, so that's where I'm going to put it. Now, by default, I'm going to put the square root of 1 minus x squared on the bottom. Following the pattern now, if I derive x, I get dx. That gives me the cosine of theta d theta. I also need an expression for the root, so I relate this side to this side. That is adjacent over hypotenuse. That's the cosine of theta is equal to the square root of 1 minus x squared. And now I use these 3 equations to substitute it into my original. This is going to be the integral of sine of theta on the top. I've got the square root of 1 minus x squared, which is the cosine of theta on the bottom. That to the 3rd power. And I take out my dx and I replace it with the cosine of theta, d theta. All right, here we go. Cosine cancels with one of those. That gives me the sine of theta over the cosine squared of theta. Here we go back to first semester now. What I'm going to do is I'm going to split this. I'm going to do sine over cosine, which is the tangent of theta, and I'm going to do 1 over cosine, which is the secant of theta, d theta. Secant of theta d theta anti-derives to the secant of theta plus c. I cannot have an answer in terms of theta, so I go back and I look at my triangle. Secant is hypotenuse over adjacent, so it's 1 over the square root of 1 minus x squared plus c. All right, I think that should be enough to get you through the homework. Please come see me when you return. I'll work you through any problems that you might be having. Best of luck down there. Thanks.